percent error. So let's kind of talk a little bit about what percent error actually is. And percent error shows the difference between an experimental value compared to the real or known value as a percentage. And so that's kind of the big thing, is that we're looking at what we kind of determined in the lab versus what might be a known or real value. For example, a lot of different values, such as the speed of light, the speed of sound, the mass of the earth, like all of these things have been experimentally determined over and over and over again. So those are considered real or known values. Now, when we're talking about numbers in lab experiments, these numbers can be misleading because it depends on the magnitude of error overall that's based on a known measurement. For example, let's just talk about the Earth. If you measured the circumference of the Earth and you are off by 1,000 miles, that's a huge amount, right? But in reality, that's only a 4% error because of the just magnitude of the size. But let's just say something, if you measured the length of a piece of paper or a paper clip and you were off by only a half a centimeter, that's almost a 13% error. So keep in mind, there's huge differences just based on what you're actually trying to measure. And so let's talk a little bit about the kind of percent error equation. And so our percent error equation is the absolute value. Remember, that's what these brackets represent. The absolute value, which means it's always positive, of the actual value minus the experimental value, meaning what you determined. So I'll say, the you determined value divided by the actual value. And so the key here is the fact that you're comparing a value that you found versus a well-known or well-documented value. And so when it comes to percent error, we generally say that a percent error of less than 10% is good. And so if you're within 10% of what you're supposed to be, we're A-okay. So let's look at some examples. So here we have Joe and Susan, who are performing an experiment in a lab to test the density of aluminum. From their data, they determined the density to be 2.65 grams per milliliter. They checked the table on the lab and found the actual density is 2.70 grams per milliliter. So what is their percent error? And so remember, our percent error equation is the actual value minus the experimental value divided by the actual value. And so in this case, our 2.70 represents, we'll label this our actual value, while our 2.65, on the other hand, represents the experimental value. And so that's a big key here, is understanding which is which. Now, it doesn't really matter for the top, but in particular, it matters what you divide by. And so for this, it's the absolute value of our actual value. Now, in this case, our actual value is 2.70, and the experimental value, meaning the one the students determined, was 2.65. And then it's all divided by the actual value again, which happens to be 2.70. And then remember, it's multiplied by 100%. And so as we go through this, we know 2.70 minus 2.65 is 0.05, and then divided by 2.70 and multiplied by 100%, this gives us a percent error of 1.85%. All right, so Joe and Susan did a pretty good job. So let's look at another example here. And this time, we have Sam and Bob, and they were performing an experiment to test the boiling point of water. Now, what they found is that the boiling point of water is 98.4 degrees Celsius. So what was their percent error? Now here, we do need to tie in some kind of previous knowledge, and we hopefully know that the actual value for the boiling point of water is 100 degrees Celsius. Now, if you didn't know that, that's okay, not a big deal. On like tests, quizzes, everything else, I'll give you those values, but overall, it's an easy number to remember. And so with this, let's now kind of go through our percent error. And remember, our percent error should be equal to our actual value minus our experimental value divided by our actual value. And so if that is true, that would mean it's 100 minus 98.4 divided by 100 and then times 100%. Ooh. Then times 100%. And so now as we go through this, 100 minus 98.4 should give us 1.6 divided by 100 and then times 100. We're going to end up getting 1.6% error. All right, so Sam and Bob did better than Joe and Susan even. And so now let's talk about you and your lab partner. And so you guys are trying to determine the mass of a solid that is remaining after a reaction. Now, a lot of times we call this a precipitate in chemistry. And so precipitate is just a fancy way of saying like solid after a reaction occurs. And so you record the mass to be 0.33 grams. Now, the known value of the solid is 0.45 grams, meaning this is how much you are supposed to actually end up getting after the reaction occurs. So, what is your percent error? Okay, well, if we think about it, just like we did our other examples, our percent error is equal to our actual value minus our experimental value divided by our actual value. So in this case, the actual value, meaning the value that we're supposed to have, is the 0.45 grams. So it would be 0.45 minus our experimental value, which is what you found in this case. So that's the 0.33 grams. And then all divided by the actual value that we were supposed to get, 0.45. So as we go through this, 0.45 minus 0.33 divided by 0.45. And so after we do this, we multiply by 100%. And in the end, this ends up giving us a 26.7% error. So notice that's actually a pretty big percent error. But remember, it's all in relation to the magnitude of the measurements. So because these measurements are so small, like 0.45, 0.33, like these are really tiny, especially when you compare them to like our last example where we're talking about the boiling point of water, where we're talking about like hundreds. And so that's just something to kind of keep in mind in terms of percent error, is that yes, we're shooting for under 10%. But in terms of the values, the smaller the value, the harder it is to get within that 10%. All right, that's it for this video. See you guys on the next one.